In this video, we find the slope of the graph of a polar equation. So we've got a polar equation. R is given as a function of theta. If I want the slope of the graph, just the traditional slope, change in y, instantaneous change in y with respect to x, it's simple. All I have to do is use the formulas that we use in the parametric equation section. Except this time, instead of our parameter being the variable t, our parameter is theta. Now, in order to do that, you need to find y as a function of theta and x as a function of theta, and that's done pretty easily. All you do is use the fact that x equals r cosine theta, and you replace r with whatever that function is in terms of theta, and you do the same thing with y. You replace r with r of theta here, and now you've got a function of theta equals x and a function of theta equals y. You can take those derivatives, divide, and that will give you dy dx. And of course, that's provided the denominator is not 0. Now, if the numerator is 0, but the denominator isn't, well, then we're going to have a 0 divided by some non-zero number, so we'll get 0. So here are some implications of this formula. If y prime is 0, but the denominator isn't, x prime isn't, we have a horizontal tangent line. So that slope is going to be 0. Now, if the denominator is 0, but the numerator isn't, well, we know we can't do this, but if you have a non-zero number over 0 as the denominator, as that x prime of 0, or x prime of theta approaches 0, this quotient will approach positive or negative infinity. And what that means for us is the slope is undefined because it's approaching positive or negative infinity. But what that represents geometrically is a vertical tangent line. So our tangent line is going to be equal to, like, x equals a constant, and it's going to be x equals whatever x is as a function of theta at that point. Now, if x prime and y prime are both 0, this is undefined. You've got a 0 over 0, and you can't say anything about the tangent lines there. Okay, so let's do this. We've got an r of theta, it's 1 minus sine of theta, and we want to find the slope of the curve at this location. So the first thing I'll do is I will find x and y in terms of theta. And it's very simple. Remember, x was r cosine of theta. So now, instead of writing an r here, you're going to replace r with 1 minus sine of theta. So you're just substituting. R is being replaced by 1 minus sine of theta, and you still have that cosine there. So that's your x, and y will be r times sine of theta, but r is 1 minus sine of theta on this curve. Oops. So y is r sine of theta, so we get 1 minus sine of theta times sine of theta, not cosine of theta. So this is my x as a function of theta, and this is my y as a function of theta. Once I have x and y as functions of theta, I'll just differentiate with respect to theta and divide. So we need to compute y prime of theta and x prime of theta. Now you've got options here. You can either distribute and then differentiate for each of these, or you can use the product rule. I think I'll distribute this time. So y is equal to 1 minus sine of theta times sine of theta, and we want to distribute that sine to both terms. So if sine of theta times 1 is sine of theta, minus sine of theta times sine of theta is sine squared theta, or you can write it this way just to remind yourself that you have to use the chain rule when you take the derivative. And then we'll compute, after simplifying, we'll compute y prime of theta. You don't have to distribute first. You can use the product rule, but I chose to do this instead. Okay, so the derivative of sine of theta is cosine of theta. Then we bring the negative down, and the derivative of a function squared is 2 times that function times the derivative of the inside. The function is sine of theta, and the derivative of sine of theta is cosine of theta. So that's our y, or excuse me, our y prime. Y prime of theta, and now we need x prime of theta. I'll distribute here as well, distribute the cosine. X is, actually we're gonna end up with a product rule anyway, so let's not distribute that time. Let's just write this as 1 minus sine of theta times cosine of theta. Since we have to use the product rule for sine times cosine, it really doesn't benefit us to distribute. Okay, so if I want the derivative of x with respect to theta, I need the product rule. I need to use the product rule. So I'll call that my first function and that my second function. The derivative of a product is the derivative of the first, which is negative cosine of theta, times the second, undifferentiated, plus derivative of the second, derivative of cosine is negative sine, times the first, undifferentiated. And then we can simplify. We get negative cosine squared theta here, and I can distribute now. Negative sine times 1 is negative sine, don't forget your angle, and a negative times a negative is a positive sine squared. Okay, so we're here now. All right, now I'm trying to find slope at a particular point. So I need to compute dy dx. That'll give me a formula for the slope in terms of theta. And then I'll just substitute in my theta equals pi over 4. And that'll give me the slope at that location. Okay. So dy dx is y prime of theta over x prime of theta. And that turns out to be cosine of theta minus 2 times sine of theta times cosine of theta, all divided by x prime, which was, looks like sine squared minus cosine squared. Or if you prefer, you can write it this way. It's not simplified, but that's fine. It makes it a little bit easier to see what we have to do. And our goal is to find the slope at this point, and we see at this point, theta is equal to pi over 4. So we want to evaluate this at theta equals pi over 4. Okay. Now with a 45-degree angle, that's pretty fortunate and pretty simple. We know sine and cosine of pi over 4 are square root of 2 over 2. So we'll have square root of 2 over 2 here, square root of 2 over 2 here and here. And in the denominator, we'll have the same thing. And then it simplifies. That reduces. In the numerator, we've got square root of 2 over 2. And that 2 will reduce with one of those 2's. And this root 2 times root 2 is 2. So we've got 2 over 2, which is a 1. All divided by negative root 2 over 2. Yes, we could multiply everything by square root of 2 over, or negative square root of 2 over negative square root of 2. And my choice there I made that choice because I wanted this denominator to simplify to a 1. And a negative times a negative would make that a positive, and root 2 times root 2 is 2, so I'd have 2 over 2, which is 1. When I distribute, this times this is going to give me a negative 1, and this times that gives me a positive root 2. Down here, this gives me the 1 that I wanted, and I see that my slope is that number. So square root of 2 minus 1, and that's about 0.414. Okay. Now it would be helpful if we could see the graph and see what this looks like. I think I want to do one more thing before we look at the graph of this. Now let's say we were given the same function and someone asks us to find the points of horizontal and vertical tangency to the curve. In other words, they're saying, where will we have a horizontal tangent line? Where will we have a vertical tangent line? And remember what we talked about earlier. So we're going to have a horizontal tangent line whenever the slope is 0. And the slope is 0 when y prime is 0. So the numerator is 0, but the denominator isn't. So we get a slope of 0. And then if you flip it, so the denominator is 0, and we have a non-zero number in the numerator, we get a vertical tangent. So if somebody asks you for the points of horizontal and vertical tangency, they're just saying, set both of those equal to 0, solve for theta, make sure you don't have any theta values that cause both of those to be 0. And those are going to correspond to points of horizontal and vertical tangency, or at least those are going to correspond to the theta coordinates. Then we'd find the corresponding r values by substituting the thetas into the original function, r of theta. So we have the same function. R is equal to 1 minus sine of theta. And earlier we said that y of theta was sine of theta minus sine squared theta. And that implied that y prime of theta was cosine of theta minus 2 times sine of theta times cosine of theta. Now, in order to find the points of horizontal and vertical tangency, I just need to set y prime equal to 0 and x prime equal to 0 and rule out any values that cause them both to be 0. And like that's where we'll start. So first you set y prime equal to 0 and solve for theta. Well, this is pretty nice. I've got a cosine here and a cosine there. And so I can factor that out. It's very nice. And then I set that equal to 0. So I've got a product that equals 0. So that means either the first factor is 0 or the second factor is 0. Now cosine is 0 at all of the odd multiples of pi over 2. And we can represent an odd number by 2 pi n, where n is an integer. And if you're not sure about that, you can look at the cosine graph. That's pi over 2, 3 pi over 2. You'll see it crosses the x-axis again at 5 pi over 2, 7 pi over 2, negative pi over 2, negative 3 pi over 2, and so on. That's one way of doing it. You can also look at the unit circle. And remember, cosine is 0 when the x value is 0. X is 0 here and here. So that's pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, or negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on. Either approach, this way or this way, you get cosine is 0 at all the odd multiples of pi over 2. And over here, if I solve this for sine of theta, I'll subtract 1 from both sides, divide by 2, negative 2, and I get sine is 1/2. Well, that's going to happen infinitely many times. It's going to happen twice every period. Now, if I go to the XY plane and start drawing some triangles, I know sine is positive in quadrants 1 and 2. I want the hypotenuse to be 2, the opposite side to be 1, because sine is opposite over hypotenuse. And those reference angles, well, that's a 1, 2 square root of 3 triangle. Since it's opposite the 1 in a 1, 2 square root of 3 triangle, that angle is 30 degrees, that reference angle in either case. So here, you've got theta equals 30 or 150. But of course, we have to convert to radians because we're in calculus class. That's pi over 6 or 5 pi over 6. That's on one period, but then we need to be able to add n pi as many, or 2 pi as many times as we want. So this is theta equals pi over 6 plus 2 pi n, where n is an integer, and theta equals 5 pi over 6 plus 2 pi n, where n is an integer. So y prime is 0 here and here. Okay, so if x prime is not 0 at the same locations, then we have horizontal tangent value or horizontal tangent lines at these values of theta. Okay, now let's look at x prime. So x prime was this. We have sine squared minus cosine squared minus sine of theta. Now the problem with this is I've got two trig functions, cosine and sine, and it doesn't factor nicely like this one. It eventually factored until I had two equations involving a single trig function, and then I could solve those equations pretty easily. But that doesn't happen here. So I've got the sine squared and the cosine squared, and this cosine squared doesn't have anything in common with these guys, but we know how sine squared and cosine squared are related to each other, right? Sine squared plus cosine squared is 1. Since I know that sine squared plus cosine squared is 1, I can write cosine squared in terms of sine squared by subtracting sine squared from both sides. So I've got cosine squared is 1 minus sine squared. The angle is theta. And this is helpful because now I've got x prime entirely in terms of sine. Let's distribute the negative, and we end up with sine squared theta and sine squared theta, so that's 2 of those, minus sine of theta, minus 1, and I think that factors as well. So I've got a 2 sine squared theta here. First times first has to be this. So one of these is probably 2 sine of theta, and the other one is probably sine of theta. So first times first gives me that. They get a negative 1. I know this is 1 and that's 1. One of them has to be positive and the other one has to be negative. If this factors, it has to factor this way. So the question is, well, which one should be positive and which one should be negative so that that sign in the middle has a negative SIGN sign out front? I think this one should be negative and that one should be positive. If you guess wrong, you can always flip it later. Let's distribute. First times first is that. Outer times outer is negative 2 sine theta. Inner times inner is positive 2 sine theta. So we get that. Last times last is that. Good. Okay, so now we can solve this for theta. I've got this times this equals 0 because we're setting it equal to 0 and solving for x. That's good. That means this factor is 0 and this factor is 0 when sine equals negative 1/2. This factor is 0 when sine equals positive 1. Okay, so now we just have to solve those two trigonometric equations. Now, if I'm looking at a single period of the sine function, it looks like this. We're going to have two solutions on a single period for that equation, sine of theta equals -1/2. This is the x-axis. That's the y-axis, and that's that horizontal line, y equals -1/2. So we get two solutions, and they're between pi and 2 pi. So I guess we kind of knew that. So I think I'm going to draw some triangles in the xy plane. Sine is negative when y is negative. The side opposite the angle is -1, the hypotenuse is 2. So this is another 1, 2 square root of 3 triangle. And our reference angles are still 60, or they're still 30 degrees. They're opposite the ones in those triangles. Since that's in quadrant 3, we end up with 180 plus that 30 degrees. So theta, I've got sine of theta equals -1/2. Theta will be that 180 degrees plus that 30 degrees, or 210. But we don't think, or we think that way, or I think that way, but I'd like to convert to radians. So that's pi plus pi over 6, that's going to be 7 pi over 6. Or we're over here, that's 360 minus that 30, so it's going to be 330. Or it's 2 pi minus pi over 6, or 11 pi over 6. And then we can add or subtract 2 pi as many times as we want. So we get 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. Notice that these do not have any values in common with these. And I'm just going to say note to self, sine of theta equals -1/2 for both of these. That will be helpful when I find the corresponding r values a little bit later. So that was that first equation. And the other equation is sine of theta equals 1. We see that that happens there at pi over 2. It only happens once every period, but then it repeats. So we can see sine of theta equals 1 implies theta equals pi over 2. We can add and subtract 2 pi n as many times as we want. So I've got pi over 2 plus multiples of 2 pi. And I think I will also have something like that here. These are odd multiples of pi over 2. I think for all of these, we're going to end up with an odd multiple of pi over 2. Aren't we? Let's factor out a pi over 2. Is that right? I factor out a pi over 2. I guess I need a 4 there. Yeah, 4n times pi over 2 is going to give me 2 pi n. Okay, so this is 4n plus 1. 4n is even, no matter what n is. If I add 1, that's going to be odd. So these are all odd multiples of pi over 2. And these are odd multiples of pi over 2. So at all of those values, that's where at all of these values, which are actually a subset of these values, we're going to have a problem because y prime and x prime are both equal to 0. But at the other ones, at the odd multiples of pi over 2 that satisfy this equation but not this equation, then we have a horizontal tangent line, but and no problem. Okay, so let's sort of get all of this together. This is sine of theta equals 1. These are the values of theta that give us sine of theta equal to 1, or x, and also x prime equals 0. And these give me sine of theta equal to -1/2, and y prime, or excuse me, x prime equals 0. And these give me y prime equals 0. Okay, so if someone asks you for horizontal tangent lines, where are those points of tangency? That's when y prime is 0, but x prime is not 0. Well, we know that y prime is 0 and x prime is not 0 when theta equals pi over 6 plus 2 pi n, or theta equals 5 pi over 6 plus 2 pi n. In both of those cases, that corresponded to a sine of 1/2. Sine of theta equals 1/2. Okay, so the question becomes, where are those points, horizontal tangent lines? Well, they're given by r values with corresponding theta values, and r was 1 minus sine of theta. So we'll have r equals 1 minus sine of theta, which is 1/2, and these theta values. So pi over 6 plus 2 pi n. So we're going to get 1/2 and pi over 6 plus 2 pi n. And r theta equals 1/2 and 5 pi over 6 plus 2 pi n. So those are our two solutions, or those are two of the locations where we will have a horizontal tangent line on the graph of our curve. Now, this one leads to horizontal tangency when we've got an odd multiple of pi over 2, which is not simultaneously one of these odd multiples of pi over 2. Let's expand this out a little bit. We're going to have pi over 2, and then we're going to have 5 pi over 2. So these solutions look like this. Pi over 2, then we add 2 pi, so you have 5 pi over 2, then 9 pi over 2, and then 13 pi over 2. So in the numerator, we're adding that 4 pi every time because of that 4n. And then over here, y prime is 0 whenever theta is equal to pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2. We don't get all of these. We can't have y prime and x prime 0 at the same time. So y prime is 0 at 3 pi over 2 and 7 pi over 2 and 11 pi over 2, the one after that, when x prime isn't at those multiples of pi over 2. Okay, well, how is that related to this? Well, if I take 4n and I add 1, that gives me these odd numbers. To get these odd numbers, I think I would have to take my 4n and then add 3, wouldn't I? So we'll say y prime of theta equals 0, while x prime is non-zero when theta equals odd multiples of pi over 2 that are not a member of this family. So 3 pi over 2, 7 pi over 2. So we take 3 pi over 2 and we keep adding 2 pi, 11 pi over 2, and so on. Okay, so let's see. For those values, let's see what the sine function would be. Sine looks like this. That's 3 pi over 2, and that's 7 pi over 2. So if we keep adding 2 pi to that, our sine is going to equal 1, or excuse me, -1 at that point. If you're saying, why does that even matter? It's because r is equal to 1 minus sine of theta, so we need to keep that in mind. Okay, so here theta is equal to 3 pi over 2 plus 2 pi n. That's when y prime is 0, but x prime isn't. And r is equal to 1 minus sine of theta, but sine of theta is negative 1 in all of those cases, so r is equal to 2. So r theta is 2 and 3 pi over 2 plus 2 pi n. Okay, so I've got these guys, and these guys. Those all correspond to horizontal tangent lines of my original graph, and that's because y prime is 0 and x prime isn't. Now vertical tangent lines. We have vertical tangent lines when x prime is 0, but y prime isn't 0. And we've already done some calculations for that. Okay. X prime is 0 here, but all of those are ruled out. Those are problems because at these values, y prime is also 0. But at these values, x prime is 0, but y prime isn't 0. So those are the thetas that we have, and then to find the r's, we just do 1 minus sine of theta, which is 1 minus negative 1/2. So theta equals, it looks like 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. And those correspond to sine being negative 1/2. So r is 1 minus sine of theta, and theta is given by these values. So we're going to have 1 minus a negative 1/2, and theta is given by those values. So we'll have 3/2 and 7 pi over 6 plus 2 pi n, and 3/2 and 11 pi over 6 plus 2 pi n. These correspond to vertical tangent lines. Now this video is getting kind of long, so I'll stop. But it would be helpful to graph this function and then just look at the curves at these locations, and we would see at this value of r and this value of theta and this value of r and this value of theta, we have a vertical tangent. And then over here we would see that when r theta is equal to this or this, we have a horizontal tangent line, and if r theta is equal to this, we have a horizontal tangent line. And then we might be able to see what happens at those interesting values where x prime and y prime are both 0. That's these guys. Very curious what happens there. Okay, so that's it for this video.